Question 31. Which of the following statements correctly explain or explains why an increase in temperature increases the rate of a chemical reaction? So, increase in temperature. Increase in temperature increases the rate of the reaction. So, what is the reason for this? At high temperature, the activation energy of the reaction is decreased. No, that is wrong. Because activation energy, there is temperature cannot change the activation energy, because activation energy is a unique value for a particular reaction. Activation energy is a unique value for a particular reaction. Therefore, activation energy doesn't change on the temperature change. So, at high temperature, activation energy of reaction is decreased. No. At high temperature, activation energy of the reaction is increased. No. Because there is no change in activation energy with the temperature change. At high temperature, products are formed from every collision of reactant molecule. Here they say every collision, which is wrong. Right? We can't form products from every collision of the reactant molecules. Because for a reaction to occur, there are some factors for a reaction to occur. First one is they should collide with each other. And next, they should collide with proper orientation. And also, they should have sufficient energy to overcome the activation energy barrier. To overcome the activation energy. Right? So, those are the factors that should be satisfied. Now, every collision can't give products, because if the collision doesn't happen in a proper orientation, then we can't form products. So, every collision doesn't give products. Then at high temperature, the fraction of collisions having energy greater than the activation energy of the reaction is increased. What about that? So, that is Maxwell-Boltzmann distribution. Now, here, if we plot a graph like this, and if we plot a graph as the energy of the molecules and fraction of molecules. Now, if we plot like this, right? This is at T1, this is at T2, and T1 is greater than T2, which means at high temperature, right? At high temperature, what should happen? This graph should shift towards the right direction. It means now in this direction energy increases now. So this is energy of the molecules, right? Energy of molecules. So in this direction energy increases. Therefore the graph should shift towards the right direction at high temperature, right? So at high temperature, the fraction of collisions having energy greater than the activation energy of the reaction is increased, right? That is the answer. So, at high temperature, what happens? The amount of, the fraction of collisions happening increased because the energy is high. Right? So the fraction of collisions having energy greater than the activation of the energy is increased. Therefore, we are having the graph more shifted towards high energy side. Right? So here only D is correct. Therefore, the answer is 5. Answer 5, and it is only D is correct. Right. We'll move on to the 32nd question. Of the following, which alkyne or alkynes can give 3-ethylhexane on catalytic hydrogenation? So first we'll draw the 3-ethylhexane. 3-ethylhexane. Now it has hex. Hex means 6 carbons are there. Then third carbon has an ethyl group. 1, 2, 3. Third carbon has an ethyl group. Then others are N. N means alkane is formed. So you can write CH3, CH2, CH. Then CH2, CH2, CH3. So this is 3-ethylhexane. Now upon catalytic hydrogenation, the alkyne should give this product. This should be the product. Right? So this one. When this one do the catalytic hydrogenation, first see whether ethyl is present in the third carbon. Yes, ethyl is present in the third carbon. Next, here it has 6 carbons. Right? Next, we'll see whether it gives this product upon hydrogenation. Then this will give CH2, CH3. So A is correct. B, HC triple bond C. First we'll see whether there are 6 carbons. 1, 2, 3, 4, 5, 6. 6 carbons are there. Then ethyl group. Ethyl group is bonded here for the second carbon, not for the third carbon. So this is wrong. Then here, again here there are 6 carbons and the ethyl group is bonded to the third carbon. Now if we see upon hydrogenation, it gives here CH2 and CH3. So it gives this compound, right? Here, this is the ethyl group bonding carbon of CH, CH2, CH3. Then in this side it has CH2, CH3. CH2, CH3 is there. And then CH2, CH2, CH3. CH2, CH2, CH3. So C is also correct. D, 6 carbons are there and ethyl is bonded to the third carbon. Here it gives CH2, CH2, CH3. So that is correct. Then answer D is also correct. So for this, the answer will be 5. Answer will be 5. Why? Because A, C and D, 3 answers are correct. Answer 5 and A, C and D. Next, 33rd question. Which of the following statements is or are correct? A. Boiling point of a liquid decreases when the pressure is increased. Boiling point of liquid increases when pressure is increased. Then at the top of Mount Everest, water can be boiled at temperature less than 100. Water cannot be evaporated in a closed rigid container. So this is regarding boiling point and the temperature. Right? You all know that in the definition, boiling point means at the boiling point, right, what happens? The saturated vapor pressure of the liquid, saturated vapor pressure is equal to the external atmospheric pressure. Right? So, until the saturated vapor pressure becomes equal to the external atmospheric pressure, right, the vapor pressure increases, right, until it becomes equal to the external atmospheric pressure when we supply the temperature, and the temperature at which the saturated vapor pressure and the external vapor pressure, external atmospheric pressure are equal is the boiling point. So boiling point of a liquid, first statement tells that boiling point of liquid decreases when the pressure is increased. Boiling point decreases when pressure is increased. No. Boiling point should increase. Boiling point should increase when pressure increases. Why? Because when the pressure increases, the external atmospheric pressure becomes high. Then the saturated vapor pressure also should become high. Therefore, we have to supply more temperature to come for the saturated vapor pressure to be equalized for the external atmospheric pressure, because now the pressure is high. So, boiling point of a liquid decreases when pressure is increased. That is wrong. Boiling point of a liquid increases when pressure is increased. Yes, that is the answer. When the pressure is increased, the boiling point is increased, because when the pressure is increased, the saturated vapor pressure should also increase. In order to increase the saturated vapor pressure, we have to supply more temperature and the boiling point of the liquid increases. On the top of the Mount Everest, water can be boiled at a temperature less than 100. Yes, that is correct, because at high altitude, when the altitude is increased, right, the pressure decreases. Atmospheric pressure decreases at high altitudes. It means at mountains, at hilltops, the atmospheric pressure is lower. So when the atmospheric pressure is lower, the saturated vapor pressure is also low. It means we have to supply less temperature for the saturated vapor pressure to be equal to the external atmospheric pressure. So the boiling point will be low. So therefore we can boil water at a temperature less than 100. Then water cannot be evaporated in a closed rigid container. No. We can reach up to the boiling point. We can reach to a boiling point in a closed rigid container. Why? Because even it is closed, if this saturated vapor pressure is equal to the external atmospheric pressure, it will boil. Therefore, water can be evaporated in a closed rigid container. Therefore, D is wrong. So the answer is B and C. Answer is 2. 34th question. Which of the following statements is so true with regard to P block elements and their compounds? So this is an inorganic question. The reaction of PCl5 and SCl2 with water gives H3PO4 and sulfur as one of the products respectively. So let's see the reaction of PCl5 with water. PCl5 with water. PCl5 with water gives H3PO4 plus HCl. Then in order to balance this, we have to put 5 HCl, then 4 H2O. So 4 H2 8H, 3 plus 5 8H, and phosphorus is balanced. 4 oxygens are there and 5 Cls are there. Then SCl2 with water gives H2SO3 plus sulfur plus HCl. When we balance this, 4 HCl, sulfur, H2SO3, 3 H2O and 2 SCl2. So here then it will become 2S. 2S, 2S, 2 times 2, 4. 4 Cl, 3 H2, 6H. Now here should be 2, right? H2 and 4, 6H is there. Right, this is balanced. Now, the reaction of BCl5 and HCl2 with water gives H3PO4. Yes, H3PO4 is given. And also, with HCl2, sulfur is given. So, this answer is correct. Part A is correct. Part B, reaction of Cl2 with water and decomposition of H2O2 are examples for disproportionation reactions. So what is disproportionation? Disproportionation means the same species of reaction, the same species undergoes both oxidation and reduction. Okay. Now H2, first we will see the reaction of Cl2 with water. Cl2 with water gives HOCl plus HCl. Now no need to balance here. We will check the oxidation states. Here it is plus 1 because here it has OCl minus. O is minus 2, Cl is plus 1. Here Cl is minus 1. Here Cl2 oxidation number is 0. 0 to plus 1 it is oxidation and 0 to minus 1 it is reduction. So the same species chlorine, it undergoes both oxidation and reduction. Therefore it is a disproportionation reaction. Next, the decomposition of H2O2. When H2O2 is decomposed, it gives H2O and oxygen. Then here we have two both. Peroxide oxygen means here it has minus 1. Here minus 2, here 0. Then minus 1 to minus 2, reduction has occurred. Now oxidation number of oxygen in H2O is minus 2 because H is plus 1, 2 H's are there, so plus 2, here should be minus 2. Oxygen here, O2 gas, it has 0 oxidation number. And in peroxide, the oxidation number is minus 1. Then minus 1 to 0, it is oxidized. Therefore, it is also a disproportionation reaction. Therefore, reaction of Cl2 with water and decomposition of H2O2 are examples of disproportionation reactions, that is correct. A product obtained in the reaction of Cl2 with excess NH3 can be used to disinfect water. Now what happens with excess NH3? Now NH3 with use another color. NH3 with Cl2. If NH3 is present in excess, it will give ammonium, N2 and ammonium chloride. Now what happens if there is no excess? The normal reaction will be what? NH3 plus Cl2. NH3 plus Cl2 will give N2 plus HCl. Here 6, then 2, 3. Then if it is NH3 plus excess Cl2, if it is excess Cl2, it will give NCl3 plus HCl. NCl3 plus HCl. Right? About to disinfect water. Right? So with excess ammonia you form N2 and NH4Cl. So both of these we cannot use for the disinfection of water. So it does not give any products which can be used to disinfect water. So we cannot have a product that can be used to disinfect water. So that is wrong. The one which we can use to disinfect water is this NCl3. Right? That is if we react with excess chlorine. Right? Not with excess ammonia. Then SO2 cannot act as a reducing agent. That is also wrong, because we know SO2 can act both as an oxidizing agent and reducing agent. Both as an oxidizing agent and reducing agent. SO2 can act both as an oxidizing agent and reducing agent. Now, how it forms these both stages? Now, SO2, it can reduce to sulfur. So, I'll use another color. SO2 can reduce to sulfur. Sulfur has 0 oxidation number and SO2 here it has +4 oxidation number. So it can reduce to sulfur and SO2 can oxidize to sulfate. SO2 can oxidize to sulfate. Therefore SO2 can both reduce and oxidize. Therefore SO2 can act both as a reducing agent and oxidizing agent. So SO2 cannot act as a reducing agent means reducing agent, what does it do? It undergoes oxidation. No, it can undergo oxidation as well. Next, 35th question. Which of the following statements is so correct regarding the reactions of alcohols? The leaving group of the reaction between alcohols and HBr gives bromoalkane, giving bromoalkane is OH minus. No, the leaving group is not OH minus. This leaving group is not OH minus. Leaving group is not OH minus because here it forms, now the mechanism is like this now. Reaction between alcohols. So we'll take an alcohol like this, primary alcohol, with HBr, right? HBr. Here H delta plus, here delta minus. So here it has 2 lone pairs in oxygen. So it takes this H and here Br gets a lone pair. Then this will form CH3CH2O and HH. Here it will have a plus charge and here Br minus is formed. What happens next is what? CH3CH2 plus is formed, and why it forms CH3CH2 plus? Because this bond is given for oxygen. Then it forms what? Water. It forms water. And here Br minus is there. This Br minus goes with this. And it forms CH3CH2Br plus H2O. Therefore, the leaving group Therefore, H2O is the leaving group here. Right? Not OH minus. Right. Next, part B. Some alkenes can be prepared by heating alcohols with conc H2SO4. Now here they have given some alkenes. Yes. Because all alkenes can be prepared by heating alcohols with conc H2SO4, that is wrong. Because only some alkenes we can form by heating alcohols with conc H2SO4. So, now, if we show the reaction, if we take for example again a primary alcohol CH3, CH2, OH with conc H2SO4. What does it give? This OH and another H from this one goes and forms water. Then it will form CH2, CH2 double bond plus H2O. Right? And yes, but the adjacent carbon should have hydrogen to remove H2O. Why? Now, if I take a compound like this, and here it has CH2OH, right? Now, this OH should have another H to move as H2O. So, from where this H comes? This carbon does not have any hydrogens. So, as it does not have any hydrogens, we cannot form a double bond here. Therefore, this adjacent carbon need to have hydrogen to remove it as H2O. Right? So, only some alkenes can be prepared by heating alcohols with conc H2SO4, that is correct. Alcohols react with HI to give alkali iodides only when Lewis acids are present. What about that? That is wrong. Right? That is same as the alcohol reaction with HBr. Right? Only when Lewis acids are present, that is wrong. Then, primary alcohols do not produce turbidity even when subjected to the Lucas test, because primary alcohols are soluble in water. What is Lucas reagent? Lucas reagent is this. Zinc chloride, anhydrous zinc chloride. We have to use anhydrous zinc chloride and conc HCl. So this is the Lucas reagent. Now when we have a primary alcohol, now primary alcohols now we have to take. So if we take a primary alcohol like this with this Lucas reagent, right, it will give CH3, CH2, Cl. This takes so much time to occur, and this does the turbidity is very less. Turbidity is very less. Why? Because only a small amount of alkyl halides are formed. Because only a small amount of alkyl halides are formed. Therefore, we see a less turbidity there. Now, let's see what the statement says. Primary alcohols do not produce turbidity when subject to the Lucas test because primary alcohols are soluble in water. No, primary alcohols are soluble in water. The reason is primary alcohols do not produce turbidity. That is because this one will be dissolved in water or a less amount of CH3CH2Cl is formed. So as there is less amount of CH3CH2Cl, we can see that there is less turbidity. It means like it is dissolved in water. We can see a high turbidity there, right? So it will not produce a turbidity. The reason is this CH3CH2Cl is formed in less amounts and it is dissolved in water. Therefore, we cannot see a turbidity, right? The primary alcohols are soluble in water. That is not the reason. That is wrong, right? So here the C statement is wrong because only when Lewis acids are present. That is wrong. Right? The same mechanism as we did for A is there. Right. Let's move to the 36th question. 36th question. Which of the following statement is so correct with regard to the colors observed for precipitates or solutions with excess sodium hydroxide and excess ammonium hydroxide when they are added separately to aqueous solutions of each of the following cations: cobalt 2 plus, nickel 2 plus, copper 2 plus and zinc 2 plus. Now what happens when we add excess sodium hydroxide to cobalt 2 plus? Cobalt 2 plus, excess sodium hydroxide, it gives cobalt hydroxide. This is a pink precipitate. Next we are having what? Excess ammonium hydroxide. Excess ammonium hydroxide. So when we are having excess ammonium hydroxide, it will give the amine complex CONH3 6,2 plus. So this is a yellow brown color. Yellow brown color. So let's see the answers. Cobalt 2 plus gives a brown precipitate. From that also it is wrong because it gives a pink precipitate, right? Then nickel 2 plus gives a blue precipitate and green solution. Let's see nickel 2 plus with excess sodium hydroxide, right? So I'll write it as part 1. Excess sodium hydroxide, it will give nickel hydroxide, which is a green precipitate. A green precipitate will be given, and with excess ammonium hydroxide, it will give a amine complex NH3 6,2 plus, and this complex is dark blue color. So when we go for the answers, nickel 2 plus gives a blue precipitate, that is correct, and also it gives a green solution respectively. Sorry, nickel 2 plus gives a blue precipitate, that is wrong because nickel 2 plus gives a green precipitate. Nickel hydroxide is a green precipitate and green solution, no, that is wrong. Next we'll go for C. Copper 2 plus gives a blue precipitate and dark blue solution. Let's see. Then copper 2 plus. So copper 2 plus, it will form copper hydroxide, which is a blue precipitate, and with excess ammonium hydroxide it will form amine complex, that is NH3 plus, right? And this amine complex is dark blue in color. Dark blue. So here Cu2 plus gives a blue precipitate and a dark blue solution respectively, that is correct. So C is correct. Zinc 2 plus gives a colorless solution and colorless solution respectively. Right, let's see zinc 2 plus. Zinc 2 plus with first one, excess sodium hydroxide, it will give zinc OH4 2 minus, which is a colorless solution. Colorless solution, and with ammonia it will give zinc NH3 2 plus, which is a colorless solution. Colorless solution, right? So zinc 2 plus gives a colorless solution and colorless solution respectively. Yeah, that is correct. So answer is 3. C and D are correct. For the 36th question. Next 37th question. 37. Which of the following statements is or are correct? Addition of phosphate fertilizers to soil contributes to increase in N2O level in the atmosphere. So that is phosphate fertilizers. So how can phosphate fertilizers be involved with these nitrogen gases? Right? So it should be not phosphate fertilizers, right? It should be a nitrogenous one to give N2O. So that is wrong. 37 part A is wrong. Because they say when we add phosphate fertilizers, we will increase N2O. No, it should have nitrogenous compounds to give N2O, right? So that is A is wrong. Next, B. Respiration of farm animals such as cattle and goats contributes to the increase in CO2 level in the atmosphere. No. If we say the respiration of the animals like cattle and goats increase for the carbon dioxide in the atmosphere, then we all animals, we release carbon dioxide to the atmosphere. Then we all should contribute, right? So that is not the case. So here they are telling now in livestock farming, you all know that CH4 is released due to the anaerobic decomposition of the fecal matter by the action of anaerobic bacteria. Right? That one releases CH4 which will affect for the global warming. But here it is not the case. So B is wrong. C. Fossil fuel burning contributes to the increase in CH4 level in the atmosphere. No, fossil fuel burning does not give methane. Right? Fossil fuel burning gives what? Carbon dioxide. Mainly it gives carbon dioxide. Therefore that is wrong. Right? Then burning of fossil fuel does not contribute to the increase in carbon dioxide level in the atmosphere. Now biodiesel, we form it using the plant matter, right? And we cut trees to obtain the biodiesel and we again plant trees. Therefore, it does not contribute to increase in the carbon dioxide level in the atmosphere. We can take it as correct. So the answer is 5 and that is only D. Next 38th question. Which of the following statements is or are correct regarding the reactions given below? The reaction is this, right? Cu OH twice solid equilibrium reaction with Cu2 plus aqueous and 2OH minus aqueous. Right? First statement, increase in the pH of the solution decreases the solubility of CuOH twice. Right. So we are increase in pH means what? When pH increases, what happens? pH increases because OH minus concentration increases. You all know that in basic conditions the pH value is higher. So if the pH is increased, the OH minus concentration is higher. Then if the OH minus concentration is higher, what happens? This product side OH minus concentration becomes higher, and as this is an equilibrium reaction, therefore the reaction will tend to move backward. Right? Therefore the reaction will tend to move backward. Right? So what they are telling is increase in the pH of the solution decreases the solubility of CuOH twice. Yes, Why? Because of this. Right? OH minus concentration increase. When OH minus concentration increase, backward reaction is favored. Backward reaction is favoring means the solubility will be lowered. Right? It will decrease the solubility of copper hydroxide. Part B. Addition of sodium hydroxide solid into the solution does not change the solubility of CuOH twice solid. Addition of sodium hydroxide. Now, again when we add sodium hydroxide, what happens? OH minus concentration. Now we are adding sodium hydroxide now. So the OH minus concentration is increased. Again when the OH minus concentration is increased, the reaction tends to move in the backward direction. So when the reaction moves in the backward direction, again CuOH twice solid is formed, which means the solubility is decreased. So the solubility is decreased. So what they say, addition of sodium hydroxide solid into the solution does not change the solubility of CuOH twice. That is wrong. Right? Why? Because it decreases the solubility of this reaction because it decreases the solubility of CuOH twice. C statement, solubility of CuOH twice is independent of temperature. That is wrong. Why? Because this is this goes with KSP, right? Solubility product. So you all know that KSP is equal to Cu2 plus aqueous concentration times OH minus aqueous concentration squared. So this KSP, this depends on temperature. Right? So when there is high temperature, KSP increases. So it changes with temperature changes. Therefore, solubility of calcium hydroxide is independent of temperature. That is incorrect. Addition of more CuOH twice solid to the solution does not change the solubility of CuOH twice solid. That is correct. Because for the solubility product depends on copper 2 plus aqueous concentration times OH minus aqueous squared concentration. Therefore, even if we add more CuOH twice solid, right? We add in the solid CuOH twice solid. Even if we add more CuOH twice solid, it will not affect for the solubility. It will not change. It does not change the solubility of CuOH twice. But if it is like this, if we totally remove CuOH twice, what happens? I told that when we add some CuOH twice more, it will not affect for the solubility. Right? It does not change the solubility. But what if I say, if I totally remove all the CuOH twice present and now the solution does not have any CuOH twice solid, then this equilibrium will break down. Because for the equilibrium, CuOH twice solid is needed. Right? Now I am telling CuOH twice solid is needed to maintain this equilibrium, but adding some or change in the amount of this CuOH twice solid, it does not affect for the solubility of CuOH twice. Right? So that is correct. Therefore, the answer is 4 because A and D is correct. A and D is correct. Next, we'll move on to the 39th question. Which of the following statements is or correct regarding the trans-esterification reaction of biodiesel production? So this is regarding the production of biodiesel. Now what are the steps in the biodiesel production? So if we, now what are the raw materials for biodiesel? We need plant oils, then CH3OH, and we need sodium hydroxide. So the raw materials that we need for the biodiesel production right? So those are what? We need plant oils. From that we get glycerol, right? And we need methanol, CH3OH, and we need sodium hydroxide, which we take it as the catalyst. So we need these raw materials. Then they are telling, right, so we have to go through the steps also, because in the production process of biodiesel, the question is about that, right? So what are the steps there? We have to clean the plant oils first. So the plant oils are cleaned. Cleaned means the free fatty acids are removed from plant oils. Why we have to remove the fatty acids, free fatty acids from the plant oils? Because if those free fatty acids are present, they can form soap with the sodium hydroxide. So we have to remove these free fatty acids, right? Next one is second step. What is now? First step is we have to clean the plant oils. It means we are removing the free fatty acids. Then what is the second step? Second step means we are adding the sodium hydroxide catalyst and we form a catalyst mixture. Catalyst mixture is sodium hydroxide and methanol. Sodium hydroxide and methanol. So this is the catalyst mixture and this is added. Next, third is what? We have to react the trans-esterification reaction happens. In the trans-esterification reaction, the triglycerides plus CH3OH, right? It will do the trans-esterification giving biodiesel and glycerol. Right? Triglycerides with CH3OH gives biodiesel plus glycerol. Now triglycerides, it is like this. Triglycerides are there. And this should react with 3CH3OH to give the biodiesel. Biodiesel is what? So biodiesel is RCOOCH3. Wait. Biodiesel are COOCH3. This is biodiesel. And what is the other one formed? Glycerol. Right? That is OH, CH2, CH, OH and CH2OH. So that is glycerol is formed. So glycerol is a byproduct, that is correct. Bases cannot be used as catalyst, that is wrong, because here we used sodium hydroxide as a catalyst. Presence of free fatty acids is favorable for the reaction? No, because if fatty acids are present, they will form soap, right, and not involve in the formation of biodiesel. Activity of the catalyst is decreased due to the formation of soap. Yes, that is correct. Because if there are free acids, if there are free fatty acids, not acids, if there are free fatty acids, they will react with this sodium hydroxide and they will form the soap. Therefore, this sodium hydroxide concentration will be lower and the effect of the catalyst will be lower. Therefore, the activity of the catalyst is decreased due to the formation of soap. That is correct. So, the answer is 4 here, which means A and D are correct. The 40th question, which of the following statements is so are correct regarding the gases present in a liquid fossil fuel burning vehicle exhaust? Now, liquid fossil fuel burning means it is like the burning of this petrol and diesel. Right? Liquid fossil fuels, it is like what? Petrol and diesel. You can take the petrol and diesel combustion. Right? Petrol and diesel combustion. So, now exhaust. They are asking about the gases present in the liquid fossil fuel burning vehicle exhaust. The exhaust contain gases that contribute to photochemical smoke. Yes, because you all know that vehicle smoke contribute to the photochemical smoke, because in traffic conditions, right, with sunlight, that those gases, they are at high traffic cities which have high traffic conditions, we can see this photochemical smoke. Therefore, liquid fossil fuel burning, that exhaust contains gases that contribute to photochemical smoke. That is correct. Exhaust contain gases that contribute to global warming. Very correct, because it has gases like carbon dioxide which contributes to global warming. Exhaust gases contain gases that contribute to acid rain. Yes, because there are some oxides of nitrogen which can be released, and these nitrogen oxides, when they are oxidized, they will form like NO2 and N2O5, and those will react with water and they will form nitric acid and forms the acid rain. Therefore, the exhaust contain gases that contribute to acid rain. That is correct. Right? Then part D, the exhaust contain gases that contribute to ozone layer depletion. Yes, because oxides of nitrogen like NO, right, they can initiate the chain reactions which can dissociate O3. So the reactions which can dissociate O3, they can initiate chain reactions which can dissociate O3. What are the ones? Like oxides of nitrogen. Those can initiate chain reactions in order to dissociate O3. Right? So the fossil fuel combustion is involved. Therefore, from this question we can see that fossil fuel combustion involves in the major environmental problems, right? Photochemical smoke, global warming, acid rain, ozone layer depletion. So the answer is what? 5 here. All are correct. 41st question. H2S gas can act as a reducing agent as well as an oxidizing agent under suitable conditions. So that is correct. H2S can both oxidize and reduce. So H2S, when it acts as a reducing agent, it undergoes oxidation. It undergoes oxidation. Then what happens in oxidation? H2S is converted to sulfur plus 2H plus 2 electrons. Here sulfide minus 2, here sulfur 0. So it is oxidized. Right? And also H2S can act as an oxidizing agent. So H2S as an oxidizing agent means it undergoes reduction. So how H2S is reduced? H2S is converted to H2 plus S2 minus. So here it gives, now here we have to consider the oxidation number of H, right? So we'll see the oxidation number of H. This is plus 1, here it is 0. So here it is reduced from 1 to 0. Therefore, H2S can act as a reducing agent as well as an oxidizing agent under suitable conditions. That is correct. Sulfur is a nonmetal with oxidation numbers in the range of -2 to +6. Yes, it has oxidation numbers from -2 to +6. Right, so like these oxidation numbers sulfur has. Right, so from -2 it has like example H2S. Right, and then from 0 it has S8. Then sulfide ion we can take for -2. For 0 S8. Then for +2 SCl2. Then +4 SO2. And also sulfide. Sulfide also +4. Sulfur is in +4 oxidation state. Then +6 for H2SO for sulfate ion. Therefore, sulfur is a nonmetal with oxidation numbers in the range -2 to +6. That is also correct. Now, both first and second answers are correct. But here the second answer does not explain the first one. Because first it says it can act as a reducing agent as well as an oxidizing agent. But in the second answer they say about the oxidation numbers in which sulfur can range from -2 to +6. So there is no connection among these two. Therefore, the answer for 41st question is answer 2. Next, 42nd question. Boiling point of propanol is less than the boiling point of butane. So first we will draw this propanol. Propanol means, prop means there is 3 and on means it is a ketone. So we have a compound with 3 carbon atoms and there should be a ketone. So the structure will be like this. Propanol. Right. Next is less than the boiling point of butane. Butane means it is an alkane with 4 carbons. So this is the structure of butane. So when we consider the boiling point, we have to consider 2 factors. One is the molecular mass and other one is about the intermolecular interactions. Now, how about the molecular masses here? Here we have 3 carbons, so 3 times 12, 36. 3, 6 hydrogens and O, 16. Here we have 58. Then what about here? 1, 2, 3, 4. 4 carbons giving 48. Then 4 times 12, 48. Then hydrogens 3, 5, 7, 10. 10 hydrogens. So here also we get 58. So the molar mass is, molecular mass is same for both. Then what about the intermolecular interactions? Now this propanol, it has dipole-dipole interactions. How does it get dipole-dipole interactions? Dipole-dipole interactions. How does it have dipole-dipole interactions? Due to this carbonyl carbon and this oxygen, delta plus and delta minus, because there is a difference in the electronegativity is there. Therefore, it is having a dipole-dipole interaction, and also there are London interactions. But when we consider this alkane, it does not have any dipole-dipole interactions. It has only London interactions. Therefore, higher interactions are present in propanol. Therefore, the boiling point of propanol should be higher than the boiling point of butane. But in this answer, they say boiling point of propanol is less than that of the boiling point of butane. So that is wrong. First answer is wrong. Second one, propanol contains a 5 bond, whereas butane does not contain a 5 bond. Yes, propanol contains a 5 bond. So out of these two bonds, we can take one bond as sigma and one bond as phi. But you cannot see any double bonds in this alkane. Therefore, this alkane, this butane does not contain any phi bonds. But propanone has a phi bond. So this is correct. Propanone contains a phi bond, whereas butane does not contain a phi bond. So the answer is 4. Fourth answer. Next, under certain conditions, 43rd question. Under certain conditions, the pressure of a real gas sample could be lower than that predicted by the ideal gas equation. So this is regarding the real gases and ideal gases. So first one, it says under certain conditions, pressure of real gas sample can be lower than the predicted ideal gas equation. Now we know ideal gases, they have less, or we can consider their interactions as negligible. They have negligible intermolecular interactions, or we can consider they have no intermolecular interactions. But real gases, they are having some amount of intermolecular interactions, right? They are having some amount of intermolecular interactions. Therefore, the pressure of a real gas sample can be lower than that of the ideal gas equation. Why? Because when there are intermolecular attractive forces within the molecules, they will stay as attracted together, and the pressure will be lower. But in ideal gases, the amount of intermolecular forces is less, right? Therefore, their pressure is high. So under certain conditions, the pressure of a real gas sample could be lower than that predicted by the ideal gas equation. That is correct. The reason is real gases, they have intermolecular attractions within them. Therefore, their pressure is lower because molecules tend to be attracted together. Now, second answer, intermolecular attractive forces are present among real gas molecules. Yes, that is correct. So, intermolecular attractive, now in real gas molecules, intermolecular attractive forces are present, but we cannot see any intermolecular forces, intermolecular attractive forces within ideal gas molecules, right? But we can see intermolecular attractive forces are present in real gas molecules. And this second answer explains well the first answer, right? So why the pressure of real gas sample is lower than the pressure of an ideal gas? The reason is due to the presence of intermolecular attractive forces among the real gas molecules. So both answers are correct, and the second explains the first. Therefore, answer is 1. Next, 44th question. The electronegativity of manganese is lower than the electronegativity of chromium and iron. So this is regarding the 3D block elements. 3D elements, right? So here, if we write the 3D elements, I can write scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Now, you all no need to know these electronegativity values. In order to explain the answer for this question, I'll show the variation of the electronegativity by giving the values. But no need to know these values, right? So these are rough values: 1.4, 1.6, 1.6, 1.7, 1.6, then 1.8, 1.9, 1.9, 9 and 1.7. So what happens now? Here to here, up to chromium, the electronegativity has increased. But here the electronegativity has dropped in manganese. Then again from iron to zinc, electronegativity has increased, but at zinc electronegativity is dropped, or we can say it is lower. It is lower. So what is the reason for this? Now if we consider about the electronic configurations, the electronic configuration of chromium, we know it is 24 now. So it will give a configure. Now if I take the valency configuration, the valency configuration of chromium will be 4s1 3d5, right? Or we can write 3d5 4s1 because of the rearrangement. Then manganese, it is 3d5 and 4s2. Then again iron, that is 3d6 4s2, and zinc, that is 3d10 4s2. Now these configurations are stable configurations. You all know that. These are stable configurations. So when they are in stable configurations, their electronegativity values are lower. Therefore, manganese and zinc has lower electronegativity values than their adjacent atoms. So we can't actually say it generally increase, because at manganese there is a drop. It is like the bat shape here. Now here to here it has increased and it has dropped, right? Again increased. Now it is like this. From a higher value it has dropped, right? Dropped. So the at the middle. So that is due to this stable configurations present in manganese and zinc. So the first statement is the electronegativity of manganese is lower than the electronegativity of chromium and iron. Yes, it is lower than the electronegativity of chromium and iron. The electronic configuration of manganese is more stable than the electronic configurations of chromium and iron. Yes, the manganese electronic configuration is more stable than chromium and iron. That's why the electronegativity of manganese is lower. So the second gives the reason for the first statement, and both are correct. Therefore, we can go with answer 1. Next, 45th question. 45th question. Aromatic diazonium salts when warmed with water form phenols. So let's take this. Aromatic diazonium salts. So it is like this now. N2 plus Cl minus now here. N2 plus Cl minus reacts with what? When warmed with water. So with water, right? With water, what does it give? When warmed with water, it gives phenol plus N2 will be released. A phenol is formed and N2 is released. N2 gas is released. So first statement they are telling aromatic diazonium salts when warmed with water form phenols. That is correct. First answer is correct. Then aromatic diazonium ions are electrophiles. Yes, they are electrophiles. Why? Because they have the plus charge here. Right? Therefore, they are attracted to electrons. So they are electrophiles. But aromatic diazonium ions, their action as electrophiles does not explain for the aromatic diazonium salts to react with water to form phenols. Right? It is not due to this aromatic diazonium ion action as a electrophile. That it is not due to this reason. Right? Aromatic diazonium salts form phenols. It is not the reason as aromatic diazonium ions are electrophiles. So that is not the reason for that. And therefore the answer is 2 for this 45th question. Answer is 2. 46th question. In an electrochemical cell, the electrode having the lower reduction potential acts as the anode. Yes, that is correct. Because we know that now we have to consider the E0 values in order to find the anode and the cathode, right? We have to consider these electrode potential values now. So if the E0 value is lower, lower E0 value, it is given for the anode, and the higher E0 is given for the cathode. That's how we select the anode and the cathode. So in an electrochemical cell, the electrode which have the lower reduction potential acts as the anode. Then in an electrochemical cell, electrons are easily released from the electrode with comparatively low reduction potential. Yes. Why? Because lower reduction potential means that is the anode, and it undergoes what? Oxidation. In oxidation, electrons are released. Electrons are released. So that is correct. And what can you say? It is answer 1 or 2? That is answer 1. Because the second gives the reason for the first one. Right? Therefore, it is answer 1. Next, 47th question. In the production of nitric acid using Ostwald method, NO gas is reacted with O2 gas at a temperature higher than the temperature at which NH3 gas is reacted with O2. So here we have to, you all have to know the reactions of this Ostwald process in the production of nitric acid, right? So if I write the reactions, now first this one happens now, NH3 plus O2 giving NO plus H2O. So this happens at a temperature of 800 to 850 degrees Celsius. Next, NO plus O2, right? NO plus O2 gives NO2, and here the temperature is 150 degrees Celsius. So lower temperature is for this one. Here the temperature is lower for this reaction. What they say is, in the production of nitric acid using Ostwald method, NO is reacted with O2 at a temperature higher than NH3 with oxygen. No, NH3 with oxygen has a higher temperature, and next NO, the formed NO is reacted with O2 to give NO2 at a lower temperature. So this is wrong. Next, high temperatures are not favorable for reactions with negative entropy changes. Now, this favorable word, if this favorable word comes now, we have to check whether it is spontaneous and non-spontaneous thing now. For that, we have this equation, delta G equal delta H minus T delta S. Right now, they are telling high temperatures are not favorable for reactions with negative entropy changes. Now here, if the entropy change is negative, right now, here we have the minus T delta S now. Minus T delta S now we are getting. So minus into minus, this term becomes plus T delta S. And when this plus term increases, delta G can be positive. Can be positive when this plus term increases. Right? So we can say that high temperatures are not favorable for the reactions with negative entropy changes, because negative entropy, then here we get minus sign, Then minus T delta S term, what does it become? Minus times minus, it becomes plus. Right? Then when we increase the temperature at high temperatures, when we increase the temperature, the positiveness increases, positivity increases. Therefore, delta G tends to become positive and the reaction will not be favorable. Right? So, first statement is wrong and second statement is correct. Therefore, answer is 4. Next, the partition coefficient of a solute is temperature dependent. Now, not only partition coefficient, we know partition coefficient is also included for the equilibrium constant. Any equilibrium constant is depend on temperature, right? Any equilibrium constant depends on temperature. Equilibrium constant changes upon any temperature change. So, even though it is Kd, you all know partition coefficient is Kd, no? Even though it is Kd, or Ksp, or Ka, Kb, Kw. So, all these, they change with the temperature. Therefore, you all must remember, any equilibrium constant is temperature dependent. Any equilibrium constant depends on temperature, right? So, the partition coefficient of a solute is temperature dependent. Yes, we can tell any equilibrium constant is temperature dependent. Then second statement says, the solubility of a solute in different solvents changes by the same amount with temperature. Now, here you all must know this one. Solubility changes with temperature, right? But it changes according to the solution. So, we can't find that every solvent will change their solubility with the same amount at the same with the temperature. Right? We can't say like that. We can't say that the solubility of every solvent is changed by a same amount by the temperature. No. It depends on the solution, because from solution to solution they have different intermolecular interactions. Therefore, the solubility changes from solution to solution. Therefore, solubility changes with temperature. That is correct. Solubility changes with temperature, but the solubility varies according to the solution that we use. Therefore, the solubility of a solute in different solvents changes by same amount with temperature. Wrong. That is due to this word. We can't say it changes with same amount. Right? So, this second one is wrong. Therefore, we can go with answer 3 for the 48th question. Next, 49th question. First statement, during the production of sulfuric acid, SO2 gas is converted to SO3 in several steps. So, we'll write the production process of this sulfuric acid. So, the reactions which involve in the production of sulfuric acid are these. Sulfur plus O2 gives SO2. Then SO2 plus O2 gives SO3, and that is an equilibrium reaction. And then SO3 reacts with H2SO4 to give volume, H2S2O7, and H2S2O7 with water, it gives H2SO4. So, these are the reactions which occur in the production process of sulfuric acid, right? So, this is the equilibrium reaction and this is the reaction they are asking about, right? SO2 is converted to SO3 in several steps. Now, as this is an equilibrium reaction, you will think that it happens in a single step. No, it does not happen in a single step, because we use, because when SO3 is formed, right? When SO3 is formed, more SO3 is there. So it will tend to move backward. So it will tend to move backward and it will favor the backward reaction, decrease in the rate, right? So because of that, we use a catalyst also here, V2O5, and we use this catalyst in 4 catalytic surfaces. We send this reaction in 4 catalytic surfaces. Catalytic surfaces. In order to increase the rate of the reaction, in order to prevent this reverse reaction. Because when SO3 is formed, as this is an equilibrium reaction, it will tend to move in the reverse rate, the reverse reaction will tend to happen. In order to avoid this, we are using a catalyst and we send this reaction, we make this reaction to happen in these 4 catalytic surfaces, right? Therefore, it happens in several steps here. So, the several steps means this thing, right? It is not this one, right? We have to consider several steps as this because it is sent through several catalytic surfaces for the reaction to happen. We cannot directly convert this SO2 to SO3 in a single step. It happens in several steps with the catalytic surfaces, with multiple catalytic surfaces, right? So this is correct. Then complete conversion of SO2 to SO3 in a single step is not spontaneous under the conditions used in sulfuric acid production. Complete conversion of SO2 to SO3 in a single step is not spontaneous. Yes, that is correct. Why? Now, why it is not spontaneous? Because the reverse reaction can tend to occur, right? When SO3 is being formed, right, it will tend to move in the, it will tend to make the reverse reaction to happen, right? So, because the reverse reaction can occur when more SO3 is produced, it can be non-spontaneous if we do it in a single step. So, in order to favor this reaction, we have to do it in several steps by sending it through several catalytic surfaces, right? So, this is correct and we have to go with answer 2. Because second does not explain the first. Next one, the last question. HFC, hydrofluorocarbon gas, does not contribute to ozone layer depletion in the upper atmosphere. That is correct, right? HFC, it does not contribute to ozone layer depletion. Why HFC does not contribute to ozone layer depletion? Because HFC does not form radicals, radical chlorides, right? Because HFC doesn't form chlorine radicals, therefore it does not contribute to the ozone layer depletion, right? That's why HFC doesn't contribute to ozone layer depletion. So what is the importance of these chlorine radicals? Now if these chlorine radicals form, they start to form chain reactions in which the ozone will be depleted, right? So if chlorine radicals are formed, then those are contributing to ozone layer depletion, but here HFC does not form chlorine radicals, therefore HFC does not contribute to ozone layer depletion. Then second statement, HFC is quickly destroyed in the upper atmosphere by breaking the CF bond. That is totally incorrect, right? The reason why HFC not contributing to ozone layer depletion, that is because it does not form chlorine radicals, right? So this is the end of the chemistry 2023 MCQ paper discussion. We think that you all got a benefit from this series of videos. So study well, and if you found any part when I am discussing that you are not thorough enough in that, please go through those lessons now itself and cover those lessons, right? And all the best for your exam.